Hey guys, how's it going? Welcome to another LeetCode video programming tutorial. For today, we are going to solve problem number 62, unique paths. And this is one of the most asked Amazon interview questions. This is especially asked either in their phone interview round or their online assessment. So let's see what the problem says. It says there is a robot located on the top left corner of an M cross N grid. Now the robot can move in either downwards or right direction at any given point in time. And what we want to do is we want to find the number of unique ways that it can take while solving this grid before it can reach the finished position. So let's think for a minute. How do we solve a problem like this? At a first glance, what we see is if it wants to move to the right, there is only one unique way to reach this square. How many unique ways are there over here? Just one, because it can take right from this square, like the first square. There is only one unique way to reach this square, so because it can only move right from this, there's no other path. Like it cannot move upwards from here. It can move either in the right direction or the bottom direction. So this entire row, or the first row, it is going to be like just one unique way to reach each and every square. In the same way, if it starts moving down, in each and every square there is only one unique path. Like it can move down, so there is only one way to reach this. And there is only one way to reach this square because it can move down from over here. It cannot go left, like it is only allowed to move either down or right. So that gives us some general idea that that the first row and the first column both will have only one way to reach any of the squares. Now what about the second row? We see that, let's take this square for an example. We see that the number of ways that a robot can reach this square is either from over here or from over here. So from its top and the left square. So if we sum the number of ways it can reach both of these squares, then that should be equal to the number of ways it can reach this one. What about this blue square? Well, it can either reach over from this white square or this square. There are no other ways, there are no other directions. So all we need to do is just need to sum the number of ways that can reach from over here or here. So we just sum these two numbers. So we had initialized this entire row with 1. So this and this also 1. So number of ways it can reach the square is going to be 2. What about this? This is 2, this is 1, so this is going to be 3. And at the end, when we fill this entire grid, what we are left with is this final block, and whatever is the number over there, that must be the number of unique paths that are possible. So let's try to code this up and see if it works. And by the way, this kind of approach is called dynamic programming. I'm going to solve a lot more problems if you're interested in dynamic programming and want to learn more about this. So we are just going to create a grid. What do we want is we want 0 for row in range n, and we want to repeat this metric. So we want to create this metric. So we want to repeat this entire list for m number of times. So for column in range m, and yep. Now what do we do first? We need to initialize the 0th row and the 0th column. So for I in range n, we want to initialize the 0th row with value of 1. So each and every cell in this row will be assigned a value of 1. And then we want to assign the value of 1 in each and every cell in this column. So for I in range m, we want equals to 1. Now, what was the third step that we had to do? We just want to sum for every cell in this rest of the grid equal to this the square on the top and the square on the left. So how do we do that? So we'll loop over the entire grid from the first row. Oops. For j in range 1 comma n, and what we're going to do is we are going to assign. So ij in this would be like, it will start from 1 comma 1, so it is this square, and it is going to be sum of its top on the top square and the one on the left. Top square is going to be I minus 1 j plus dp of I j minus 1, and but that's it. That should fill the entire grid, and at the end we just return the final. We just return whatever's the number in the final box. We let's just add like basic validation. So if not am or not an, then return 0. So we need to form a valid grid. Let's try to run this, and hopefully it works. Keep fingers crossed. And it says list assignment index out of range. Okay, why does that say that? Let us see. Uh, I hope you guys have noticed it, but I'm assigning the same boxes. So if you want to assign columns, then we should be doing this. Let's run it again. Oh, great, it works. And let's try to submit this. Excellent. Uh, so this is the way in which you would solve this problem in a dynamic programming manner. Now, there is also a mathematical approach that you may take, but I feel this is slightly better way, just because there are so many variations to this problem. For example, what if there is a block or a wall in some of the squares? Like, what do you do? What do you do? So in that case, you will not be adding anything for those square, and those squares should be marked as 0. So there are other examples. If you and I'll soon be solving them and creating more videos. So if you're interested, do subscribe. Uh, do let me know in comments like if there are any other problems that you would like me to solve. And till then, have fun. Bye bye.